How do parallel lines behave when cut by a transversal? Imagine two straight lines running side by side, never crossing, like train tracks stretching into the distance. Now picture a third line crossing both of them. What happens to the angles formed? That's what we're about to explore. When a line cuts across two lines, it creates a series of angles with special relationships. If those two lines are parallel, these relationships become very predictable and useful. First, let's talk about corresponding angles. These are angles that sit in the same relative position at each intersection. For example, if the transversal crosses the first parallel line and makes an angle in the upper left corner, then at the second intersection, the angle in the upper left corner will be exactly the same. This means corresponding angles are equal when the lines are parallel. It's like looking in a mirror across the two lines. Next, we have alternate interior angles. These are angles that are inside the space between the two lines but on opposite sides of the transversal. When the lines are parallel, these angles are also equal. So, if one angle on the left inside the first line is, say, 45 degrees, then the matching angle on the right inside the second line will also be 45 degrees. This symmetry helps us prove lines are parallel or find missing angles. Then there are alternate exterior angles. These are outside the parallel lines but on opposite sides of the transversal. When the lines are parallel, these angles are equal too. For example, if an outside angle on the left side of the first line measures 70 degrees, the outside angle on the right side of the second line will also be 70 degrees. This is another key property that confirms lines are parallel. Now, let's look at the interior angles on the same side of the transversal, called consecutive interior angles. These angles are on the same side of the transversal and inside the lines. When the lines are parallel, these angles add up to 180 degrees. They are called supplementary because their measures sum to a straight line. If one of these angles is 100 degrees, the other must be 80 degrees. Finally, vertical angles are angles that are opposite each other when two lines intersect. These angles are always equal, no matter what lines they are. When the transversal crosses the parallel lines, the vertical angles at each intersection are equal, making it easier to find unknown angles. All these angle relationships work together to show us how parallel lines behave when cut by a transversal. If you see equal corresponding angles or equal alternate interior angles, you can be sure the lines are parallel. These rules are not just theoretical. They help in solving real problems involving shapes, angles, and constructions. Whether you're working on a geometry problem or designing a building, understanding these angle properties makes everything clearer. When a transversal crosses two lines, it creates a predictable pattern of angles that follow specific rules. And knowing these rules helps us understand and prove whether lines are parallel or not.